Okay, for this next graph, this next combination of functions, we've got f of x equals x and log x, g of x equals log x. We want to determine an expression for the function f times g of x. And so then, maybe I'll just write it up here, f times g of x is basically just x log x, because we're just multiplying f of x equals x times log x, which just gives us x log x. So then what you need to do, in order to use these graphs to produce the graph of this, we need to find certain values and multiply them together. So one of the easy values to find here is for f of x equals x, y equals 0 here when x equals 0. Log x has an asymptote, a vertical asymptote at x equals 0. So when you multiply anything times 0, we're still going to get a 0 here. Then if we were to find, we got a y value of 1 there and a y value of 0 for the log function, so it's going to be another 0 there. And then in between other parts along the way, we're just going to have to take some values and kind of guess along the way and see what we can find. So if we can see, this is, it's not exactly 2, that's not exactly, sorry, 0.5. It's roughly 0.5, and this is 3, so that might be about 1.5. It's an approximation. So this would be approximately 1.5 here. Then we've got, looking back here, this is about 0.5, this is maybe about 0.25. Do a quick calculation. This is 0.12, oh sorry, this is negative 0.25 roughly. So it'll be about negative 1.25. So we see that the graph is dipping down below. That obviously makes sense. So we're going to have a graph that's going to look something like this. And then if we calculate a few more points, we'll see that this continues and it's curving to take into account the curvature of the log function. And that's basically where it is. So if you want to verify, you can get a few more points along the way here. So the y value of 4 here, and the y value, and that's a little bit greater than a half, I suppose. So that will be above 2, which I have here, but I'm not sure how far above 2 it's supposed to be. So that's basically it. You can also verify by going on Desmos.com to verify what x log x actually looks like. So there's the graph that we've drawn here, and then to state the domain and range, again, the domain is x element of all real numbers such that, and what would be the domain here? X greater than and equal to 0, and then the range, y is an element of all real numbers such that, well, we see it's going down to, well, I've written there negative 0.125. It may go a little bit lower than that. It's kind of hard to tell. You could play around with a few numbers, try a few more values and multiply them together to see how much the log function here affects the line y equals x, to see if it gets even lower. Just for argument's sake, I'm just going to say it's greater than or equal to negative 0.125. Just for fun, it might be a little bit different than that, so please verify that to improve the accuracy of your notes there. Okay, so that would be another combination of functions. And so now we've got another example here where we're going to do a quotient. So we got two functions. F of x is 2x plus 1 and g of x is x squared minus 4. and we need to find an expression for that function when we're finding the quotient of them, and then use the graphs down here to draw a new graph, and then of course again find the domain and range. So f of x, or f divided by g of x, that's going to be 2x plus 1 divided by x squared minus 4. I don't think anything can really be factored out of that, so I'm just going to do 2x plus 1 over x minus 2x plus 2. I notice that this is a difference of squares. So the restrictions then, look at the restrictions for the denominator. X cannot equal plus or minus 2. So in the denominator, if there are two values that cannot be included in the domain, what does that mean about the graph, the resulting graph? Right, we're going to have a couple of vertical asymptotes. So one at x equals negative 2. And one at x equals positive 2. Okay, so we have these two functions. We got the vertical asymptote, and we need to now see what this graph is going to look like. Okay, so what I'd like you to do is, again, find common points between the two functions, get those values and divide them, and do the same thing here and here. So divide all these common points, f of x divided by g of x, and then see what the graph will look like. And then once you've done that, you can verify by looking at this graph and then even graphing that on Desmos, just to verify to make sure that I have even graphed it correctly. Also, what other feature would you have if you have a rational function like this? We've got the two vertical asymptotes by looking at the denominator. What happens generally when you're dividing two functions? We looked at this, I believe, in chapter 3 or 4. When we have two functions and we're dividing, generally also we're going to have a horizontal asymptote, so, or an oblique asymptote, but take a look at the degrees of the numerator and denominator and verify which would it be, a horizontal or oblique. And so then once you've analyzed that, please find the domain and range after you've graphed it, and then come back and check your work, please. Okay, then now you've drawn your own graph. Just verify that your graph looks similar to mine. We've got 3 branches to this graph. One of them is over here on the left, and it is below the horizontal asymptote of y equals 0, and to the left of this vertical asymptote at x equals negative 2. The right hand branch is to the right of the vertical asymptote at x equals 2 and above the horizontal asymptote of y equals 0. And then in between, we've got this little S-shaped kind of figure here that does not actually have an x-intercept of 0, but rather something between 0 and negative 1. So just verify that that is not a, the x-intercept is not a 0. It's a little bit off-centered here, and then it continues on down to the left of this vertical asymptote at x equals 2. Okay, so I just found a few, I just divided a few of these points to get a little bit of accuracy, and then just drew a sketch to see after I found what the general trend of the graph is going to look like. And then for the domain, x is an element of all real numbers such that x cannot equal plus or minus 2, which is the same as a restriction for the denominator. And then the range, y is an element of all real numbers, because this middle part, this middle branch, goes all the way down from positive infinity down to negative infinity, even though the horizontal asymptote, like I've stressed before, it does not affect anything of the graph in, around, near the origin, but rather when x gets really, really big, either positive or negative. Okay, and if you're only looking at those parts where x is greater than, or very, very large, or very, very large negative, then you would say that y does not equal 0. However, we can plainly see that y does equal 0 as this middle branch goes right through the x-axis. So that is the lesson for today. So please continue working on these questions here. Any questions with an asterisk is something that you might need to verify using graphing software like Desmos, or any sort of graphing app that you may have on your smart device. And so please start working on a few of these from these 3 sections. Start working on those at home, and then continue the rest of them in class next day. So thank you for your attention, and we'll see you in class.